Hi, do services always return what we expect? I think we all know the answer that they don't, and our code will deal with this reality one way or another. In this video, we are back to our example of collecting Pokemon attack points, but this time there are also errors in the response. I believe it is a good rule of thumb to keep our service response actionable for the caller, and while you might be using a clever tool that has the same goal in mind, but for the rest of us, this generally means that we have to retain control over how unexpected situations are handled. So let's take this response and try to make something of it. First, let's build a test code, which is just going to call our function. We are first going to use the type-based parser of Gson. And see what that can get for us. So it is a static function. It returns a list of integers, and it is called attack, get attack, Json, string Json, and it is Json is going to get us list of attack points, which is going to be a type that we define. This is going to be our attacks list, and Gson will create this for us from JSON using the JSON object, and we'll have to specify a type to work around Java's way of handling generic type parameters. So this is going to be a new type token, and the generic type of this is going to be a list of attack point, and we are going to subclass this and get the type from here. And now we can define our type. So it is going to be a static class called attack point, and it is going to have an integer field of attack. And since we are going to want to deal with the errors also, it will have to have an error field, which is going to be yet another type, attack error, which we define right now. That's another static class, attack error, and it has two fields, a string cause, as you can see above, and an integer status. Okay, now that we have all the structure, we can start working with it. So all the work will have to be done using Java, and Gson will not help us anymore. So let's do the happy path first and return the attack points from the list. We are going to use the stream API for this and just map all the attack points into the value of the attack field and collect it into a list. And now we can actually call this code, and we can see that there are 255 attack points as we expect, and for all the error responses there are nulls in the list. So obviously there are errors in this response, and we would want to fail our service one way or another, or let the caller know about this. There are two broad types of errors, and the most prevailing one is the too many requests, which is the same as the 429, which is also too many requests. And I also classify this empty response as too many requests. So let's deal with that first. We are going to want to get back if this call was throttled, and we'll also use the stream API for this. We are going to filter the attack points, and if a.attack is null, so like the empty response, or we create an optional of the error field, a.error, and we are going to filter more. If this error has a status field, and this status field is 429, or the cause is equals to too many requests, then we have a match, and so we can retain these. And in fact, we don't actually have to do a filter, we can do an any match here, which is just going to return a boolean, and we can readily check on this boolean. If we are throttled, then we can throw an exception. It's just going to be an illegal state exception. The server is busy. Please try again later. And now when we run this code, and here we go, the server is busy, please try again later. Now this is better. We at least don't have back the nulls. But even if the server was not busy, we would still get an error. So maybe this is more important to get fixed than actually letting the user know that the server was busy. So we need to filter one more time and get the correctable errors. And we are going to use that again using the Stream API filter for the attack when, and this time it's going to be a little bit simpler. We are going to use the error and filter for that. If the error status is there and it is 400, then we retain this record, and we are going to map it because we actually want to be able to print what the problem was. So we are going to get the attack error cause and collect these to a list. And now we can add the condition. If the correctable errors is not empty, then we need to throw a new illegal argument exception. Please fix your query. And now we can run the code. And it is different indeed, but not as we were expecting. Of nullable. And now we have the correct exception. Please fix your query. This is good, but as you can see, this is a lot of code. I think we can do better than this. Let's try to use Json-path for achieving the same goal. Json-path is different. Hopefully, it will be a little bit more concise. Json-path, again the test code. Let's comment out the invocation of the Gson parser version because it fails with an exception. So we can start building our Json-path implementation. It is also going to get back a list of integers, and the method is called getAttackJSON-path. It gets the JSON string, and as you might remember, this is a one-liner using Json-path. Json-path read from this string, and we have to specify a correct JSON path, and that's going to be from all records get the attack field, and when we run this code we will see 255s as we were seeing it with Gson. And now we can add the filtering for all the other special cases. So first of all, we would like to know if we are throttled. In order to be able to work with that, we will take the return value of that query into a JSON array type variable, but again, use Json-path and read from our JSON string. This time, we will use a very similar thing, but without a projection, we can actually do here an expression. And that starts with a question mark. This is how it looks like. Either there's no attack field, or there is an error with the status of 429, or there is an error cause with too many requests. And now we can add the exception throwing part. If throttled is not empty, we can throw the same exact exception as we did previously. Good. Now let's run our code. Here we go. The server is busy. Please try again later. So far so good. Now the only remaining branch is dealing with the correctable errors. And let's do that too. Again, it is going to be a JSON array, a correctable list basically, and we are going to write yet another Json-path expression for our same JSON string, and this one is going to be very similar to the one that deals with the throttled case, with the exception of course that if the error status is 400, then we want to collect the cause. So now we can check for this. If correctable is not empty, we can throw, actually we can copy this, we can throw the correctable list, and now we can run the code. Forget the add the expression qualifier, and here we go. Almost the cause from the error, and now we can run the code and see, yes, please fix your query, no such Pokemon. Okay, this is it. Thank you very much for watching, and see you in the next one.